Okay, good morning, class. So today we're going to discuss first topic, which is the real numbers. Okay, to start with, we have to review the types of numbers that make up the real number system. So let us start with this. So I have here the real number system. It is made up now of these following terms. So let's start first with the natural numbers. So natural numbers start from 1, 2, 3, and so on. Or other term of natural numbers is what we call as counting numbers. And then we have the integers consist of natural numbers together with their negatives and zero. As you can see here, we have -3, -2, -1, 0, or we can also have a smaller number than -3, such as -4, -5, until infinity of the negative numbers. Okay, so there's assigned numbers, that's what we call now as integers. Now we construct the rational numbers. Usually rational numbers, it is taken by ratio of two numbers. Okay. Thus, any rational number R can be expressed as R equals M over N. Okay, so where M and N are integers and N is not equal to 0. So the following examples of rational numbers here can be expressed in terms of 1/2, -3/7, 46, 0.17, zero point 0.6, and 0.317. So as you can see here, we write R is equal to M over N, but you can see some of the numbers are not expressed in a ratio form. But like, for example, here in 46, it's a whole number. It is understood that the denominator is 1. So therefore, 46 over 1 is just equal to 46. So if the divisor or the denominator is 1, then no need to write 1. And for the case of 0.17, the 0.17 can be written in terms of a fraction form. We have 17 over 100. And you can also follow the same procedure for the next numbers. We have to recall that division by 0 is always ruled out. So expressions like 3 over 0 and 0 over 0 are defined as undefined and indeterminate. So a number divided by 0, such as 3 over 0, is undefined, but 0 over 0 is what we call as indeterminate. Aside from the natural numbers, integers, and rational numbers, so aside from that, we also have irrational numbers. So these irrational numbers can be shown with varying degrees of difficulties, such as this. We have the square root of 3, the square root of 5, the cube root of 2, the value of pi, and we have the last example is 3 over pi squared. So those are the examples of irrational numbers. So the set of all real numbers is usually denoted by the symbol. So this is now the symbol for the real number. So I will recall this, I will write this one as the symbol of real number or real numbers. When we use the word number without qualification, we will mean the real number. So the real numbers consist now of rational numbers, integers, natural numbers, and irrational numbers. So next, we're going to study regarding the properties of real numbers. So properties of real numbers. So the first one here is the commutative properties. So I have a plus b equals b plus a is an example of commutative properties of addition. Meaning to say, if we are going to add the left-hand side and the right-hand side, the answer would be just equal. Because when we add two numbers, the order does not matter. It will not affect the sum and the product for the second term. So we have here the second example. So AB is equal to BA is an example of commutative properties of multiplication. So When we multiply the two numbers, the order doesn't matter, or the order will not affect the product. Similar also to the commutative properties of addition. Okay, so take note, when we say commutative properties, the order will not affect the sum or it will not affect the product. It depends on the operation involved. Just look at here the example. So the second property is what we called as associative property. So I have here the quantity of A plus B plus C is equal to A plus the quantity of B plus C. It says here that associative properties or the groupings will not affect the sum for addition, or it will not also affect the grouping will not affect on its product. For example, if you're going to group together first, multiply first A and B, and then multiply it to the last term, which is now C, would be just equal to A times B times C. Wherein on the right side, the grouping here is B and C is combined together, while the left-hand side, it is the first term and the second term, or the A and B is being grouped together. Or you can also form another group, but the answer would be just the same because it says in this property, in this particular associative properties, that when we add three numbers, it doesn't matter which two we add first. Or when we multiply three numbers, it doesn't matter which two we multiply first. In my own words, I would say that the groupings will not affect the sum and the product of these associative properties. And the third one is what we call as distributive property. So the first one here is A times the quantity of B plus C would be equal to AB plus AC. We're going to use distributive property. So multiply A times B. The product is AB. And then plus, the middle sign here is plus. A times C is equal to AC. Okay? And the other one, we have the quantity of B plus C times A. So the answer would be just the same. We have B times A. Since B times A can be written as AB or BA, according to commutative property, the result would be just the same if we are going to write AB times BA. Plus, we have C times A. So it could be written as AC or you can write as CA. Because of this distributive property, when we multiply a number by a sum of two numbers, we get the same result as we get if we multiply the number by each of the terms and then add the results. Okay, let us try to have some examples using the distributive property. So using distributive property, I multiply 2 times x and 2 times 3. So 2 times x, we have 2x and plus, this is middle sign. So 2 times 3 equals 6. So the product now for that, it will just give you 2x plus 6. We're just using the distributive property. And then for the second example, we have the quantity of A plus B times the quantity of X plus Y. So using the distributive property, I could multiply it first as, I can do like this as A times X plus Y. So what I did here is that I will distribute A to the group of X plus Y. And then next we have plus B times X plus Y. And then after that, I'm going to use again the distributive property. So I can use that one now. A times X, we have AX. And A times Y, we have plus AY plus, this one is B times X is BX. And B times Y, we have plus BY. And then rearranging this one in such a way, I will write x first. We have now ax plus bx plus ay plus by. Okay, so what I did here is that I just rearrange the result. For addition and subtraction, such as the number 0 is a special for addition. It is called the additive identity because a plus 0 is just equal to a. Meaning to say, a number added by 0, the sum will give you the original number. Okay, if a here is my original number added by 0, then the result or the sum is still the original number, which is now a in my example. For any real number a. Every real number a has a negative. So we have the negative of a that satisfies a plus the negative of a is equal to 0. So subtraction is the operation that undoes addition to subtract a number from another. So we simply add the negative of that number. So by definition, a minus b equals a plus negative b. So if you're going to simplify the right-hand side, it will just go back here to the original from the left-hand side. Okay, so to combine real numbers involving negatives, we use the following properties. So please take note of these properties of negatives. So number one, the negative 1 times a is equal to negative a. Okay, the example here is negative 1 times 5 equals negative 5. Property number 2, negative times the negative of a, the product is equal to positive a, because we learned from our algebra is that multiplying like sign will give you positive sign. So negative times negative equals positive. Then we have a variable a, so just write a instead of writing positive a. And property number 3, the negative of a times b is just equal to a times negative b equals the negative of the quantity of a, b. So the result would be just the same. So to illustrate this one, I will use the example here. So the negative 5 times 7 is just equal to 5 times negative 7. Because on the left side here, if we are going to give the product, so the result is negative 35. As well as here, 5 times negative 7 is also negative 35. And these expressions, these two expressions here, is just the same as the negative of 5 times 7. Because 5 times 7 is 35, and then multiply negative outside, the result would be just the same as negative 35. So this is now the properties involving with this example. And number 4, we have negative of a times negative b, so the product is equal to a b, because the sign here, negative times negative, is positive. So copy the variables here since they are different variables, so we will just write here as the product as a b. Okay, for example, negative 4 times negative 3 is equal to 4 times 3. So it's now positive 12 if you're going to write the answer. For number 5, the negative of that quantity, so the sign here inside the quantity will be changed to its opposite sign because we are multiplying negative to this quantity. So using distributive property, so negative times a will give you negative a, and negative times positive b, so the product now is negative b. Okay, so it's up for you to read now the example. And last one here, the negative of a minus b. So in this case, we are going to multiply first using distributive property. Negative times a is negative a, and negative times negative b is positive b. So what I did here is that instead of writing negative a plus b, so I am just rearranging this one. So we started writing the positive number. We have now b minus a. Okay, let us try some examples using the properties of negatives. So let x, y, and z be real numbers. So negative times x plus 2. So that can be written now as using distributive property as well as involving the properties of negative. So negative times x equals negative x, and negative times positive 2 is negative 2. Okay? So this is now similar to the property number 5. Okay? So we just change the sign inside the parentheses. Now, going back to this example, the negative times the quantity of x plus y minus z. So we are going to change the sign. So by multiplying negative outside from this quantity, so the sign will be changed. Or you may apply the properties of multiplying integers. So negative times x is negative x. Since this is positive, I will change negative y. And the negative z here, negative times negative is positive z. So in other words, class, for shortcut, so if you're multiplying negative to the quantity, we just change the sign. Okay, so from x plus y minus z, so the product now becomes negative x, negative y plus z. Or you can write also your answer as z minus x minus y. But whichever is your answer, so they are all accepted. So for multiplication and division, the number 1 is a special for multiplication. It is called the multiplicative identity because a times 1 is equal to a for any real number a. So every non-zero real number a has an inverse of 1 over a. That satisfies a times 1 over a, so the answer is just equal to 1. Or that satisfies a times 1 over a equals 1. Division is the operation that undoes multiplication. So to divide by a number, we multiply by the inverse of that number. If b is not equal to 0, then by definition, a divided by b is equal to a times 1 over b. So we take only the reciprocal of b. So the answer for this would be equal to the expression of a divided by b, or a times 1 over b, that will give us a over b. When we write a times 1 over b, simply a over b, because a times 1 is equal to a, so over b. So we copy only the denominator of b since we are just multiplying a whole number and a fraction. So we refer now to a over b as the quotient of a and b, or as the fraction of a over b. A here is the numerator and b is the denominator. And that denominator is what we call as divisor. So to combine real numbers using the operation of division, so we use the following properties. Okay, so let's start first with the properties of fraction. So number 1, we have a over b times c over d is equal to ac over bd. So what we did here, multiply numerator by numerator, as well as multiply the denominator by denominator. Okay, so for the example, so it's up for you to study the example. For the property number 2, a over b divided by c over d. So to solve for the quotient for this kind of fraction, first of all, we are going to change the symbol of division into multiplication. But you are going to take the reciprocal of c over d. So the reciprocal of c over d is d over c. So a over b, you just copy this one. So somewhat like our c over d is our divisor. So therefore, we have to write now a over b times the reciprocal of C over D is D over C. Then after that, you multiply numerator by numerator and denominator by denominator. So let me discuss this example. For example, we have here 2/3 divided by 5 over 7 is equal to, copy this first fraction, we have 2 over 3, and then change the operation from division to multiplication, but you take the reciprocal of 5 over 7, wherein the reciprocal of 5 over 7 becomes 7 over 5. Then after that, you now multiply numerator by numerator, which is 2 times 7 is 14, and denominator by denominator, we have 3 times 5 equals 15. Okay, so it says here that when dividing fractions, invert the divisor and multiply. So that is the same as what I said a while ago. Now, the third property, we have A over C plus B over C. In this kind of fraction, since the denominators are the same, so we just copy the common denominator and then add the numerators. Take note, you can only add the numerators if we have similar fractions. Similar fractions wherein the denominators are the same. Okay, so therefore, we just added the numerator and then copy the common denominator. And for number 4, we have adding fractions, but in this case, the denominators are now different. As you can see, the denominators are B and D. So in that case, class, we are going to find first the common denominator or the LCD if we are referring to the numbers, not variables or letters. So in this case now, since they are variables, then I will find the product of the denominators. So the product now is the BD, and then after finding the LCD, I call this one now as the LCD. And then after that, you divide to the denominator and then multiply to the numerator. So you can write this one now, the formula, we have LCD divided by the denominator, whatever the result, and then whatever the result, this is the answer, times the numerator. And then that is now the answer. Okay, so let's put this one. We have the LCD is BD divided by B. So the quotient now is D times A. So we have now the product of AD. And then copy plus, copy the sign, the same procedure again, LCD divided by denominator. So our LCD is BD divided by D, the quotient is B. And then whatever the quotient, you write it here in the box, that is now B times the numerator, the N is numerator, so we have now the product of DC. As you can see here now in our example, we have 2/5 plus 3/7 is equal to, find first the LCD between 5 and 7, wherein the LCD now is 35. So 35 divided by 5 is 7 times 2. We have 2 times 7 or 7 times 2. Or we can write it here as 14. 7 is 5 times the numerator of 3. So 3 times 5 or 5 times 3 are just the same according to the commutative property. So adding this one, we have 2 times 7 is 14 plus 3 times 5 is 15. So the sum of this now will give us 29, and then copy the LCD, which is now 35. So it says here in the description, when adding fractions with different denominators, find a common denominator or the less common denominator. Then add the numerators. I guess there is something lacking there When adding fractions with different denominators, find a common denominator, then add the numerator. I guess you need to follow the format here. We have LCD divided by the denominator, whatever the quotient, I write here as a box, and then multiply it to the numerator, and then whatever the product for this is what you're going to write here, okay, or here. All right. And for number 5, we have AC over BC. This is just equal to A over B because we have C in the numerator. We also have C in the denominator. When we divide that one, the C over C is just equal to 1. Or we can use cancellation. We have AC over BC, so we can cancel C and C. Therefore, the remaining variables or answer will give us A over B. Okay, cancel numbers that are common factors in the numerator and denominator. For number 6, if A over B equals C over D, then AD is equal to BC. So what happened here is that we are just AD is actually from this to this. We multiply using cross multiplication. And we multiply A times D, and we also multiply here B times C. So we have 2/3 is equal to 6 over 9. So if these two sides are equal, then you are just going to cross multiply. So we have 2 times 9 is equal to 3 times 6. We will see 2 times 9 equals 18, and we also have 3 times 6 is also equals to 18. So we just cross multiply if these two statements are equal. Okay, next example, we're going to use the LCD to add fractions. Okay, for this example, 5 over 36 plus 7 over 120. In this case, since the denominators are quite big, then to find the LCD for that, let us recall how to factor each denominator into a prime factors. So let us try to use prime factorization, but I just like to use the 3 factorization. Shall we say 36? So I have 36. So for example, we're going to write here 2 times 18, and then 18 can be factored as 2 times 9, and then 9 can be expressed as 3 times 3. So the prime factorizations here are 2, 2, 3, and 3. So in other words, the expression of 36 can be written as 2 squared because there are 2 2's, okay? And then times 3 squared because there are 2, 3 prime factors. And for the other number, we have 120. So let's try to factor out 120. So start first, what is 120 divided by 2? Or we can divide it by 5 since 120 is divisible by 5. So I will try to use first 120 divided by 5. So the factors now is 5 and 24. So I'm trying to use 5 and 24 because we know 5 is also a prime number. And then we're going to factor now 24. So the factors is 3 times 8 because 3 is a prime number. And 8 now can be expressed as 2 times 4. But 4 is a composite number. So let's factor this again. I have 2 times 2. So on the left side here is 1, 3, 2, 2, and 2 are the prime numbers. So therefore, I can write here 120 is equal to, we have 2. How many 2's do we have? There are 3. So 2 to the third power times 3 times 5. If we're going to multiply that one, 2 to the third power is 8. 8 times 3 times 5 equals 120. Now, in this case, we are now going to find the LCD by forming the product of all the prime factors that occur in this factorization. So we are going to use the highest power of each prime factor. What are the highest power of each prime factors? For starting number factors of 2, we have 2 to the second power and 2 to the third power. So the highest power is to the third power. So therefore, I'm going to use now for deciding the LCD. So we can write now here. So the highest power of each prime factor. So these are the prime factors: 2 squared, 3 squared, 2 cubed, 3, and 5. So the highest power of each prime numbers. For 2, we have 2 squared and 2 cubed. So I will get now 2 to the third power. And then for 3, we have 3 squared and just 3 to the first power. So I will take now 3 squared. And for 5, since there's no 5 here, so automatically I will write here 5 because this one has no 5 and we have 5 to the first power is the highest now. Now, after that, you multiply or simplify this one. So 2 to the third power is 8. We have 8 times 9 times 5. So what's the product for that? We have 8 times 9 times 5. So it gives us now the product of 360. So this 360 now is what we call as the LCD, or the least common denominator. So to solve for this now, we are going to write here the LCD of 360. All right. So as what I have tell you a while ago, that the LCD will be divided by the denominator. Then whatever the quotient, shall we say this is the quotient, and then times the numerator, and then the quotient times the numerator, you will say that this is now the final answer. You have the heart. Now shall I say now 360 divided by 36 equals 10. So I can write here now 10 times the quotient is 10 times the numerator is 5. So the product now is 50. So I can write here now as 50 plus, do the same procedure now. We have 360 divided by 120. The quotient is 3. So we have 3, the quotient is 3 times 7. So the product now is 21. So plus 21 here, and then add the numerator. Okay, to simplify further, we have 50 plus 21 is equal to 71 over 360. If in case the result of this can be reduced to lowest term, then you just reduce to the lowest term. But I guess for that, it cannot be reduced anymore. Now let's discuss now regarding the number line. Okay, so the real numbers can be represented by points on a line as shown in this figure. Okay, so the positive direction toward the right is indicated by an arrow. So we choose an arbitrary reference point 0, as we call that one as the origin, which corresponds to the real number 0. So given any convenient unit of measurement, each positive number x is represented by the point on the line a distance of x units to the right of the origin. And each negative number, the negative x, is represented by the point x units to the left of the origin. Okay, so the left of 0 are the negative numbers, the right of 0 is the positive number. So the number associated with the point P is called the coordinate of P. The coordinate of P, and the line is then called a coordinate line. So as you can see here, I have the red line here. This is now the point P, or the coordinate of P, and that line is what we call as the coordinate line, or the real number line, or just simply a real line. Often we identify the point with with each coordinate and think of a number as being point on the real line. So we have here, for example, this is now the black one here is 0, is the point of origin, and then this one is 1/8, next one is 1/4, and this one is zero point 0.3 bars, and then this one is 1/2 because it is now in between 0 to 1. That is the midpoint between the 0 to 1 is 1/2. Okay, so some of the number line here, the coordinate line are in between values from 0 to 1. So we also have here from this number line of 1 to 2. So we have an example, the square root of 2. So as you can see here that the value of the square root of 2 is greater than 1 but less than 2. Okay, or it has a value of, if I'm going to use a calculator, so we have the square root of 2 that will give you now as 1.41 something. Okay, so and then the other side here, the left side, so we can also write here, if there is a negative square root of 2, then it is now here on the x points to the left because that is now negative number. So I'm not going to discuss all the numbers here. So just remember that this is now what we call as the real line or the number line. So the real numbers are ordered. We say that A is less than B. To write that one, we have A less than B. This is the symbol for less than. A less than A is less than B if B minus A is a positive number. Take note, the other way of writing A less than B can be written as B minus A if that is a positive number. So geometrically, this means that A lies to the left of B on the number line. Equivalently, we can say that B is greater than A. So we can write now B is greater than A. The symbol for A is less than or equal to B, or B is greater than or equal to A. Take note. If we're going to write the symbol of A is less than or equal to B, or if we're going to do the reverse, if B will be written on the left side, that it could be written as B is greater than or equal to A. It means that either A is less than B or A equals B, because there are two symbols here, greater than or less than. And it is read as A is less than or equal to B. Okay, that's what I said a while ago, that A is less than or equal to B. For instance, the following are true inequalities. Look at this figure. So I have here 7.4 is greater than 7, and 7.4 is less than 7.5. Okay? Now this one also, we have negative pi is less than negative 3. And the other example here, square root of 2 is less than 2. And last one, we have 2 is less than or equal to 2. Now, let us start here in the first example that I said 7.4 is greater than 7, but 7.4 is less than 7.5. So this is now our 7 here, and the 7.4 is somewhere here, is 1, and the other point is for 7.5. So 7.4 now is in between 7 and 7.5. When I said in between, it is not necessary that it's in the middle of 7 and 7.5, but that is within that limit or boundary in between 7 and 7.5. Okay, so we can also use another example. We have here negative pi is less than negative 3 because pi is 3.14. So if negative, so therefore it is now located on the to the left of 0. So negative 3.14 is pi is 1, and this is only for the negative 3. So therefore negative pi is less than negative 3. Therefore, negative pi is to the left of negative 3 because a negative number closest to 0 has a bigger value. For example here, negative 1 compared to negative 2. So negative 1 has a bigger value compared to negative 2. Or could I say that negative 2 is less than negative 1? So in the same procedure here, in our example, we have negative pi is less than negative 3. As you can see in the number line, this is for the value of negative pi and this is the value for negative 3. Since negative pi is on the left of negative 3, therefore negative pi is less than negative 3.